Hello everyone, today's topic is deadlock in multithreading. I also discuss about what is the difference between the deadlock and starvation. In the previous lecture we had seen how two threads will communicate between each other by using wait, notify all, and when we use wait, notify and notify all, what are the difference between the notify and notify all? We have already covered all those topics, and this is the last topic of thread regarding thread. So first of all, what does mean the deadlock? If two threads are waiting for each other forever, such type of infinite waiting is called deadlock. Suppose thread A waiting for thread B, and thread B is also waiting for thread A. So when both threads are waiting for each other, then this situation is called deadlock situation, and that kind of problem is called deadlock problem, right? So now the question is, if I use the synchronize keyword, can we overcome the deadlock problem? Is it correct or not? No. Synchronize keyword is the only reason for the deadlock program. If I use anywhere in the synchronize keyword, then there may be a chance for the deadlock situation. So if I use the synchronize keyword in our program, so program incorrectly, then there may be a chance the program enter into a deadlock situation. So please use the synchronize keyword properly until and unless it is not necessary. It is not, if there is no specific requirement, then it is never recommended to use the synchronize keyword. So that is one of the important keyword you have to remember, why a thread it enter into a deadlock situation. So now once a program enter into deadlock, then being a programmer, what can I do? Being a programmer, what can I do? Just we have to see, that's all, nothing we have to do, because we don't have, because we can't do anything, because there is no resolution technique available for deadlock situation, but there are several prevention technique are available to prevent deadlock situation. So being a programmer, we don't require to know about the prevention technique, because it's related to operating system talk. So you should only aware how a program enter into a deadlock situation. So how we can overcome it, that part I will discuss. So in this lecture we mainly concentrate how a thread will enter a deadlock situation if I don't use the synchronize keyword properly. Let's consider an example. Suppose we have a class. I am just not writing the complete program, I am just trying to discuss or trying to show that how a thread can enter a deadlock situation. For example, this is one of my class is class A, name is A, and within class A we have one of the method. For example, T1 is a method, and it parts argument have another object B. for example. Okay. We have another method that is called, for example, last method. I am not writing the signature of the all method, just for understanding. So, the class A is end. Similarly, we have another method, another class, for example, class B. Class B, and within class B we have another method, for example D2, and it passes or takes an argument AA. Okay. And we have, for example, same method, we can take any other method also, no problem. I am just writing the same method to understand it. Okay. So, last is another method. So, both class, A class has two methods, one of the method is called D1, another method is last. B class has two methods, one of the class is method is name is D2 and another method name is last. Now, in this situation, suppose within the D1 method I want to call the last method of B. So, that means B dot last. Okay. No problem. And within D2 method I want to call last method of A class. So, A dot last. Now, let me tell you that, is there any deadlock situation? Yes or no? Okay, let me explain. First, how the program execution will flow. Suppose two thread, we have not mentioned any thread here right now. So, suppose class A start execution, it call which method? D1 method will be executed. When D1 method will be executed, B dot last method will be called, but this method is not synchronized, no synchronized method, there is a no problem. So, last method will be executed happily. In the meantime, D2 may be start and it will call the last method, and there is an, it's also a non synchronized method. So, it will execute happily. So, there is a no deadlock condition. So, keep that in mind, when we are not going to use any synchronized keyword, there is a no chance of deadlock situation. So, program will never enter into deadlock situation if you do not use the synchronized keyword. But if I use the synchronized keyword and properly, if I do not use the synchronized keyword, then there may be a chance the program may enter into a deadlock situation. So, in this program so far we have not used any synchronized keyword anywhere. Now, suppose I want to change or modify my code, I want to use the synchronize method, because two threads are executing happily. So, make it this method synchronize. Okay. So, synchronize D1, also I want to make this synchronize D2. Okay. So, synchronize D1 and synchronize D2, both methods are synchronized. So, let me explain again whether there is a deadlock situation or not. Do not worry about that, I will discuss in complete code with the help of this example. Right now, I am just trying to give some concepts regarding the deadlock, when and how it may be arise in your program or enter into a deadlock situation. So, if I use the synchronize keyword here, what will happen? Suppose B or any of the class start executing. So, D2 method start executing. So, it will call, it is a synchronized method. So, no problem. So, A will start A dot, it will call A dot last, no problem, there is a no synchronize. So, there is a chance. So, this last method will be executed happily, no problem. And this method is also synchronized, no problem, nobody is going to enter in this D1 method. So, there is a no problem, because here how many objects are there? only two object, right? One of the object is called, for example, object A, another object is called object B. Suppose T1 thread executing the object A and want to call D1 method, no problem. And suppose D2 is another thread want to execute on this B object and want to call D2 method. So there is no problem, because T1, what is, when want to execute the synchronized method, which lock is required? Which lock is required? Which lock is required? It is A. So T1 need to lock of A, right? And T2 need lock of B. So both the objects are different. We know that when you use both objects are different, there is no chance of synchronization, because both threads are executing heavily, because T1 is waiting for lock A and T2 is waiting for lock B, right? So T1 acquired the lock and executing D1 method, and then it is called B dot class method. So there, this method is not synchronized, there is no problem, so it will be executed happily. So B dot last method will be executed happily. Here also we have seen that A dot last method will be executed happily. So there is no chance of deadlock situation. Right now, up to this point, there is no chance of deadlock situation. So if I don't use the synchronized keyword, no problem, there is no chance of deadlock situation. But if I make D1 is synchronized and DT is also synchronized, there is also no chance. In this scenario, there is no chance of deadlock situation. We have already explained in this situation. So now I want to make this last method also synchronized. This last method also synchronize. Okay. Now let me explain once again. So suppose D1 start execution. When D1 start to execution, which lock is required? If any thread want to execute any synchronized method, then the current object of this class thread object lock is required. So D1 require, or T1 thread require lock of A, no problem. So lock of A, then it's called B dot start method, right? So when he call B dot start method, so to execute the B dot class method, to execute the B dot class method, this method is also synchronized. So which lock is required to execute this last method? This synchronized method belongs to B, so that means B's lock is required. In between, meanwhile, now you can think B already start his execution. So B is also get the lock and start executing the D2. So lock is already occupied by B2, because B is also at the same reason, B is also waiting for L lock. So A is already occupied the lock to execute the D1 method, and B is already occupied the lock to execute the D2 method. Nobody has released the lock yet, because D2 is waiting for to execute the A dot last method, and A is also waiting for to execute the B dot last method. So both are waiting for each other release the lock. So when both threads are waiting for each other forever, then this situation is called deadlock. Okay, so we called it deadlock situation. So we know that so deadlock situation happen only for synchronized keyword if I don't use this keyword properly. In this scenario, we have seen that when we have not used the synchronized keyword, the program execution was happily, there is no problem. Even I have used the synchronized keyword, synchronized D1, synchronized D2, there is also no problem. But when we make this synchronize for last method in both classes, then there is a situation that A is waiting for B's lock, B is waiting for A's lock. So, and this situation is never going to end it. So, a long waiting and which is not going to end at the forever, or you can say infinite waiting of thread, is called deadlock. So, in this example, if I take the programming example, just look at the code, nothing else. I have just not written anything. I have just simply give some message to understand. The code is same. I have just taken here the class A, and within class I have written public synchronize void D1, and I have passed the argument B object of B class. Just give the message system.out.println thread starting executing D1 method, and within this try catch I have just give the wants to thread sleep for sometimes 2 seconds, no problem, nothing else. Everything is same, nothing I have written anything. Just please make a note on this. Whatever I have written here, that is written here, B dot last, and the last method is just give the message inside A last method, and here also inside B last method. Nothing has been written. This is simple as it is my, if I compare with this situation, nothing has been written. Just only give some message so that you can understand. So, that is the actual code when a thread wants to enter a deadlock situation. So, to execute this program class, if I want to call class A or class B, I have taken another class. So, when the thread execution will be start, the name of the class is called my thread, extend thread class, right. So, A equal to new A, B equal to new B. So, I have created the object of A class and object of B class. Then we have used M1 is a method which will start this, the current object, this dot start. So, this will start the main method, or you can say main thread will be main thread that will be executed by main thread, that will be executed by main thread, and that will be executed by, this is main thread will be executed by main thread, and this portion of this code will be executed by child thread, right. Okay. So, then public static void main string asks my thread t equal to new my thread. So, when this thread instant will be created, my thread t equal to new thread, then t dot m1 method will be executed, then it will call the start method, then to b dot run method will be executed. So, b dot d2 will be start, and after that a dot d1 will be also executed by main thread. So, two threads are simultaneously executed, d1 method and d2 method. Okay. So, if I write the synchronize keyword, then we can say that there is a chance the program enter into a deadlock situation, and if I do not use the synchronize keyword, then there is no chance of deadlock situation in your program. The next question is, in your exam you will get that type of question, what is deadlock? Give me some example when a thread enter into a deadlock situation, or you might get, you can give this example also, or you might get some piece of code and they will might be asked that whether this part of the code is deadlock happened or not. This type of question you will get in your exam. And the next I want to say about the starvation. Starvation and deadlock are similar to each other, nothing is related to each other, nothing is different. Only small difference is that when long waiting of thread, where waiting never ends, is called deadlock. I want to say that two threads are waiting for each other. So, thread A wants that B has to complete first, then B will release the lock, and thread B also thinking that A release the lock. So, both are waiting each other forever. So that waiting will never going to end. We can say infinite waiting time, then it is called deadlock. But whenever this long waiting of thread where waiting ends at certain time, so that is the difference. When waiting ends at certain time, by certain point of time, we can say it's starvation. So that is the only different. Starvation means it's a long waiting, but it has to end at some certain point, right? So that is the basic difference between the deadlock versus starvation. So this is my term actually, deadlock versus starvation. That is the important question also. What is the difference between the deadlock and starvation? So we see that deadlock means long waiting, never going to end. Starvation means also long waiting, but going to end at the certain point of time. Long waiting, but going to end at a certain point of time. So now the question is, sir, when the low starvation will happen? Suppose we have a thread, okay? Suppose we have a thread. Suppose we have a 1 lakh of thread, 1 lakh thread, okay? 1 lakh thread. So out of 1 lakh thread, only one thread has the priority equal to 1. One thread priority equal to 1. We can say priority, for example, assume that it is 1, and all the remaining thread priority is 10. All the remaining thread priority is 10. So what will happen? Higher priority get will be chance first, then the lower priority. We already know that, we have already covered this topic, right? So all the higher priority thread will be executed first one by one. So this low priority thread has to wait for a long time. 1 lakh thread will be executed first. Less than 1, 999 will be executed first, and then the only one thread will be got the chance, right? So it's a long waiting, but the waiting has to end at a certain point of time. So that situation is called starvation. So when the low priority thread has to wait until completing all higher priority thread, it may be long waiting, but ends at certain point is called, which is nothing but a starvation. So that's all about deadlock and starvation. We'll see with an example also. So this is the last lecture of this thread chapter. Hope you have clear all those all your confusion right now. If is there any doubt, please let me know. You can call me or you can put your message to Google Classroom. Thank you. Now let's start with the coding example. Here this is the class A, and within this class we have two methods. One of the method name is called D1. One of the method is called D1. This is my method D1, and this is my last method. Okay, this is my last method. Okay, in D1 I have called a try catch block. So this thread, when D1 will be executed, first it will print thread start executing D1 method. Then after 2 seconds it will print thread T1 trying to call B's last method. Then it will call B last method, right? So this is my class A. Now come to class B. Come to class B. Here this is my T2 method, and within we have a try catch block just for to pause some time. Here 5000 long milliseconds, that means 5 seconds it will pause. Then after then it will give the message system.out.println thread 2 trying to call a class method. After that I will call a dot class method, and this is my last method of class B. Okay, now moving to the my thread class. Here I have called a equal to new a, so that means I will create instance of class A, and B is the reference variable of class B. Then this is my public void m1 method, and I have created within the public static void main, I have just created my thread t equal to new my thread, right? So this t will call m1 method, and m1 method will call, then this dot start method will be executed, and this start method will call the run method, right? Run method, you can say that this start method will call run method, and m1 method will call here from this. Okay, then d1 will call a dot d1, then d1 method will be executed, and within the run method b dot d2 method will call, then the d2 method will be executed. So first I don't know which one will be execute first, whether it is d1 or whether it is d2, it depends on the thread scheduler, you already know that. So let me execute, because I have not used any synchronized keyword, any method. So let me execute all those things. Let me execute this run method, my thread class. Let me execute. So what is the output? T1 thread T1 start executing D1 method, no problem. Then thread start executing D2 method. Then thread T1 trying to call BS last method. Inside B last method. Thread 2 trying to call S last method. Inside A last method. So now look at this. So first I am getting this line, thread D1 start method, then thread D1 trying to call BS class method. After that I am getting inside a last method, right? Similarly, when B1 is executed, class B is executed, then I got the message, thread start executing D2, thread T2 trying to call S class method, and inside B last method. So that was my output, right? You can check from here, right? So in this example I have not used any synchronized keyword. So let me modify. So there is a no deadlock right now, so no situation, because we know that when you use the synchronized keyword, then there is a question about whether we have used the synchronized keyword properly or not. Based on that, the thread will going to deadlock situation, our program is going to enter into a deadlock situation. So up to this point there is a no deadlock. So let me modify this as class public synchronize. So let me modify D1 class D1 method synchronize. Synchronize, okay, and it also modify the D2 method also synchronize. Okay, now let me execute. Is there any changes or not? So thread T1 start executing D1 method, thread start executing D2 method. So there is no change, because there is no uh, no, nothing is about whether we use the synchronized keyword or not. So that does not depend on this situation, on this scenario, or in this example you can say that. So if I want to, right now if I want to modify my class A of last method with synchronize, then again if I use the synchronize here also, so both method within this class they are synchronized, both method in class A also synchronized. So let me, what will happen, that we know that we will get first thread start executing D1 method, no problem. Similarly we will get thread start executing D2 method, then thread 1 trying to call this class method, then thread 2 trying to call LA's last method. Okay, then never they will call this last method because they will be waiting for each other. So let me execute so that you can understand. Yes, thread D1 started, thread 1 trying to this last method, thread 2 trying to call this last method, and there is, you can see that there is a deadlock condition because A is waiting for B's lock and B is waiting for A's lock. So nobody is going to perform the next last method because this method is not executed. So I will not get the output because they are waiting for A1. So inside B last method, this message also not in our current scenario. So that is the example of deadlock situation. So hope you understand the code very carefully. Thank you.